Good morning, planet Earth. I'm going to put a link to a video down below that I wish I could date. It looks like sometime in the 50s, maybe 60s, maybe. And it's about an industrial application of technology called an optical grating. So, just a listen through of it. Again, think of the time. This is, I was being born sometime around when this was being made. So, this is the sciences, the engineering I was trained on. This is where it gets applied to. I was trained on this aspect of the measurement sciences as well as others that support what these people are doing. When you look at the lab, watch the flow through of equipment behind the people and the knobs they're turning. I had training and then went on to experience the bulk of that type of equipment. The equipment's almost what I was trained on and learned on initially for its age. Look at the knobs and the buttons. I was trained in an analog world when digital was just learning how to connect to it very well, very fast. I watched the improvements in these things. The optical grating is of significance. Now you notice the machine that came from England. I worked for a company called Jarrell-Ash that made optical emission spectrometers. They had their own optical grating manufacturing machine. It's referred to, the technology is referred to in this, in that it used a linear cutting edge to make optical gratings. To make them master, it could take days or weeks, and the machine itself was located in a sub-basement of a building in bedrock of Boston because the machine had to be that stable, temperature-wise, physically, earthquake-wise. Any of those things changes could show up on that grating. That's how precise they are. So this thing talks through machine requirements, machine measurement tolerances. Well, optical emission spectroscopy requires more precision than that. So interesting things in there. Remember, this was an analog world. You didn't have computers to do all the thinking for you, the analysis for you. Now those peaks are analyzed with software and decided very quickly what they are and efficiently. So these tools got faster. The interleave of the sciences. You can hear at the end of this, without some reason, some profit reason, some improvement reason, which means profits, these things don't get used, they go unnoticed. That level of precision and technology underlies your lives, your daily lives, and your work. When you get on that aircraft, it depends on that level of precision in the measurements and the testing and the looking at to make sure that aircraft is safe for you. That's the hidden engineering, the engineering that uses the sciences, the engineers that are scientists at some points in their careers, in their walkthrough, or they may have touched against them in their quest for knowledge and understanding, and the next great button, whistle, or bell. So that's systems integration, systems engineering. So yeah, I thought it was a pretty cool video. It's very dated. We don't do videos like this very much anymore. It seems, but these were done by governments. So, there you go. Interesting video. Take a look at it.